Alright, so now we're going to talk about notation. So we need to understand all of the different notations that represent derivative. Okay, so if we have some y equals f of x, that's a function, then we can have this notation here. So we say this as, the way we pronounce this, f prime of x. That's the derivative of f of x. We could have this notation, df of x over dx, where f of x could be some function. So for instance, if you had if f of x was x cubed, then we could see dx cubed over dx. And what that's saying is take the derivative of x cubed with respect to x. Dy dx. So again, here's how you say it, dy dx. Say it with me, dy dx. You guys are a little quiet, but that's fine. I get it. It's early in the morning. Or we can say the change in y with respect to x, because that's what a slope is. Again, keep in mind, what is a derivative? Derivative is slope. What is slope representing? It's the change in y over the change in x. That's how we find slope, y2 minus y1 over x2 minus x1. Or we can see this notation. This is a little less common, or at least I think it is. Capital D, f of x, so that's the derivative of f of x. Or we can see y prime. Also means the derivative of y, or the derivative of x. So if the limit exists at x, then we say that f is differentiable at x. We'll talk about differentiability shortly. Again, these notations, crucial to understand. So, our same conclusion, limit definition of derivative, but what we want to get from this is understanding the notation, f prime of x, y prime of x, dy dx, change in y over change in x, d dx of f of x. All those are different ways we can just say, find the derivative. Or this is a derivative. Depends on what the problem's asking you to do. Because what does a derivative represent? Slope of the tangent line. Or just slope. Just say slope. Just remember that it represents slope or rate of change. Remember? Rate of change.